Hello and welcome. I am Dr. Pauline Fu. In this video, I will present probability rule, the multiplication rule, and conditional probability. So two topics for this video. One is multiplication rule, the other is conditional probability. And we'll start off by define some terminology. The first one is independent. Two events, E and F, are independent if the occurrence of event E in a probability experiment does not affect the probability of event F. This is independent, does not affect. Two events are dependent if the occurrence of event E in a probability experiment affect the probability of F. Let's take a look at example. Example 1, suppose you draw a card from a standard 52 card deck of cards, and then you roll a die. The events draw a heart and roll an even number are independent because the results of choosing a card does not impact the results of die toss. The other example, suppose two 40-year-old women who live in United States are randomly selected. The events, woman 1 survives the year and woman 2 survives the year are independent because the occurrence of one event does not affect the probability of another event. And now look at this example. C. Suppose two 40-year-old women live in United States in the same apartment complex. Okay, in the same apartment. The events, woman 1 survives the year and woman 2 survives the year are dependent. So the multiplication rule for independent events, suppose E and F are independent events, and then probability of E and F equal to probability of E multiply probability of F. This equation has condition. Two events must be independent. If two events are not independent, we have another formula. Okay, we'll introduce later in this video. Okay, example. Compute the probability of independent events. The probability that a randomly selected female aged 60 years old will survive the year is 99.186% according to National Vital Statistics report. What is the probability that two randomly selected 60-year-old females will survive the year? So from this example, we know, okay, not this one. It is here, this example here. If you randomly select two women, the survival of one woman does not affect the probability of another woman of survival. So these two women selected are independent events. Okay, So the survival of first woman is independent of the survival of the second woman. We know the survival rate is 99%. Okay, so probability of survival 0.99. The question asks you, what is the probability the first woman survives and the second woman survives? Because the first woman survives is independent with the second woman survives. They are independent events. So we use probability of the first survive multiply probability of second survive. The probability of first survive 0.99186 and the probability of second survive 0.99186. Okay, and you multiply those two numbers, you get 0.9838. So the final answer, the probability that two randomly selected 60-year-old females will survive the year is 0.9838. Another example also relates to independent events. A manufacturer of exercise equipment knows that 10% of their products are defective. They also know that only 30% of their customers will actually use the equipment in the first year after it is purchased. If there is a 1-year warranty on the equipment, what proportion of the customers will actually make a valid warranty claim? So there are two events here. One event is the production is defectiveness. The other event is use of the equipment. Those two events are independent because the occurrence of one event does not affect the probability of another event. If two events are independent, we use the formula probability of defective and use equal to probability defective times probability of use. The probability of defense is 10%, okay, 0.1. The probability of used 30%, 0.3. So the final result is 0.03. Okay. So the final answer, the probability of the product is defective and the customer used the product is 0.03. So far, we talked two independent events. The conclusion can extend to multiple independent events. Suppose E1, E2, E3, En are independent events, means any one of those events, any one of those occurrences in the experiment does not affect the probability of other events. Okay, so you have a probability of E and E1 and E2 and E3 until En equal to probability of E1 times probability of E2, etc. times probability of En. Okay. So that is a multiplication rule for N independent events. Let's take a look at the example. Okay. The probability that a randomly select female aged 60 years older will survive the year is 99.186%. according to National Vital Statistic Report. What is the probability that 4 randomly selected 60-year-old females will survive the year? Okay, 4. So let's take a look at the probability of 4 females survive the year equal to the probability the first female survive. Okay. Multiply the probability the second female survive. Multiply the probability of the third female survive. And multiply the probability of the fourth female survive. Okay, and this equal to the first woman survive is 99.186. Okay, multiply the second probability is also 0.99186. Those 4 events are independent, so you need to multiply the probability of each event together. Okay. And so what is this result? I'll use Excel. Okay. I'm going to use Excel. Equal, maybe Control C. I'm typing equal sign. So those 4 numbers times together. So this is the answer. Okay, 0.9678. So that is you have multiple independent events. You just multiply each probability. Actually, the solution is here. Okay, I already did it. Next, we'll compute a commonly used probability in statistics that is at least. Okay, compute at least probability. Let's look at an example. The probability that a randomly selected female aged 60 years old will survive the year is 99.186%, according to National Vital Statistic Report. What is the probability that at least 1 of 500 randomly selected 60-year-old females will die during the course of the year? When you have a question about at least probability, the question asks you, what is the probability at least 1 die? You found the complement event of at least 1 die. The complement event or the opposite event of 1 die is nobody die. Nobody die is the complement event of at least 1 die. Okay, and based on the complement event, the probability of A equal to 1 minus complement event of A. Some textbooks use A bar represent complement event, and some textbooks use A then superscript C represent a complement event. A superscript C. They are the same thing, okay? So we use this complement event formula. The probability at least 1 die equal to 1 minus probability of nobody die. Okay, and nobody die is the same as all people are survived. Okay. And the probability of each person survive 0.99. All people means 500 people, all 500 people survive, raised to power 500. Okay. So how we calculate this one? Again, you can use Excel. Okay, equal 1 minus 0.99186 raised to power 500. Okay. And then press enter key. You get 0.8932. Okay. So that is at least. Okay. So let's summarize what we have done for probability, including the previous lectures. Okay. So the rule of probability, there are two rules. The first rule, any probability must be between 0 and 1. When a probability equal to 0, it is impossible event. When a probability equal to 1, it is a certain event. Number 2, the sum of probabilities of all outcomes in the sample space must equal to 1. Okay, so all probability added together must be equal to 1. Last lecture, we also did if two events are disjoint events. Okay, disjoint event has another name, mutually exclusive event. And then probability E or F equal to probability E plus probability of F. This has condition. Suppose the two events are disjoint. If two events are not disjoint, the general formula is this one. Okay, probability E or F equal to probability E plus probability F minus probability E and F. And we call those two formulas addition rule. Addition rule. And then we have complement event. The probability of a complement event equal to 1 minus the probability of the event. And this lecture we just introduced, when two events are independent, probability of E and F equal to probability of E times probability of F. Okay. This has a condition. Suppose two events are independent. If two events are not independent, we'll introduce later. Okay. So that is the multiplication rule. Next, we'll talk about conditional probability and general multiplication rule. So we'll compute the conditional probability. We'll compute probability using general multiplication rule. What is conditional probability? First, the notation for conditional probability is the probability of F under condition. This vertical bar means under condition of E. Okay, or given event E. There are two interpretations of this notation. Again, I repeat. The first one, the probability of F under condition E. The second interpretation, the probability of F given event E. Okay. It is the probability that the event F occurs given that event E has occurred. Okay. So now let's compute this example. Conditional probability. Suppose that a single six-sided die is rolled. What is the probability that the die comes up 4? This is the question. I threw a die and I see number 4. So first, we list sample space. When you throw a die, the sample space is 1, 2, 3, 4, 5, 6. And the probability of number 4 is number 4 occurred just once. So you use 1/6. That is this answer. The probability that a die comes up with number 4 is 1/6. So now, suppose that the die is rolled a second time. Roll the die again, but we are told the outcome will be an even number. The outcome, even number. Now, same question. What is the probability that a die comes up 4? So this second question, given condition, the outcomes will be even number. What is the probability of seeing number 4? So this is conditional probability. So given the output are even numbers, the sample space for even numbers, number 2, number 4, number 6. Okay. So this time we calculate the probability of seeing number 4. We only have 3 events in the sample space, and the number 4 occurred once. So the probability is 1/3. Okay. The formula for conditional probability is, suppose E and F are 2 events. The probability of F under condition of E equal to probability of E and F divided by probability of E. Okay. And the probability of E and F, it is just you use the occurrence of probability E and F minus the occurrence of probability of E. So most often we just use this part here. Okay. So example, conditional probabilities on belief about God and the region of the country. A survey was conducted by the Gallup organization, conducted May 8 to 11, 2008, in which 1,017 adult Americans were asked, which of the following statements comes closest to your belief about God? You believe in God. You don't believe in God, but you do believe in a universal spirit or higher power. Or you don't believe in either. The results of the survey by region of country are given in the table in the next slide. Okay, so people asked to choose 3 statements. Which statement apply best for themselves? Okay. The first statement, you believe in God. In the East region, 204 people select this statement, you believe in God. And in Midwest, 212 select statement, you believe in God. In South region, 219, you believe in God. In West region, 152 select, you believe in God. Similarly, the second statement, you believe in God. You believe in universal spirit. Okay. How many people in the East region said, I believe in universal spirit? 36. 29 in Midwest believe, I believe in universal spirit, etc. And there are third statement, don't believe in either, don't believe God, don't believe universal spirit. So 15 people in East, 13 people in Midwest, etc. Okay. So this is the data, original data summarized in a table format. Now, question A, what is the probability that randomly selected adult who lives in East, believe in God? This is the question. Okay. The question asks you, what is the probability of believe in God under condition people from East? Okay, under condition people from East. So how do we solve this question? Okay. So the question asks you, what is the probability of believe in God? Okay, believe in God. Believe in God under condition people live in East. That is the question. What is the probability believe in God under condition from East? When you have this kind of conditional question and you are given a table, you just looking at, given the East means you just looking at this data here, the first row in the data set. Just look at this data. Don't look at Midwest, don't look at the South, don't look at West. Just look at this data, okay? When you just look at people in the East, the question asks, what is the probability of believe in God? 204 believe in God. Okay, 204. And then, how many total people in the East? 204 plus 36 plus 15. Okay, so this is the answer for given people live in the East, what is the probability that select the statement, I believe in God? So now, what is this number? So I'm going to use Excel. Equal 204 divided by 204 plus 36 plus 15. Okay, the result is 0.8. Try to increase decimal place to see. Yeah, it is 0.8. Okay. Yes, 0.8. Okay. So that is the one example of a conditional probability. Next question. What is the probability that a randomly selected adult who believes in God lives in the East? Okay, live in the East. So the emphasis is, what is the probability? Hold on, the first question, what is the probability adult who live in the East believe in God? Okay, and this second question asks you, what is the probability who live in the East? Given the condition, these people believe in God. Believe in God. That is the question. What is the probability of living in the East, given the condition, they believe in God. So under belief in God, you just focus on this data. This data is belief in God. Don't look at any other data. Just look at this data. Believe in God. Okay. So under condition believe in God, what is the probability of people live in East? See, 204 people in East. And divided by how many total people here in this data? So 204 plus 212 plus 219 and plus 152. Okay. So we are going to figure out what is this number. Okay. I'm going to use my Excel. Okay. Try to adjust the window so that you can see both windows. Equal 204 divided by 204 plus 212 plus 219 plus 152. Okay. So this one here. Okay. And the result 0.2592. Study this example carefully because it is touched upon the concept of conditional probability. So next example, murder victims. This is an unhappy topic, but it is reality. In 2005, 19.1% of all murder victims were between the ages of 20 and 24 years old. Also in 2005, 16.6% of all murder victims were 20 to 24 years old male. What is the probability that a randomly selected murder victim in 2005 was male, given that the victim is 20 to 24 years old? Okay. So conditional probability. So let's translate this question into mathematical expression first. What is the probability of the person is male given condition, given that the person is 20 to 24 years old? So this is the expression for that question. Okay. So based on conditional formula, so this equal to probability of male and 20 to 24 years old divided by probability of 20, 24 years old. Remember the formula here. See this formula, we used exactly this formula, okay? Conditional probability formula, okay? And then what is the probability of male and 20 to 24 years old? It is here, see? 16.6% are male and between 20 to 24 years old. And next, what is the probability of between 20 to 20 years old? Here, see? 19.1%. 19.1% are between 20 to 24 years old. Okay, and you do the division, you get 0.869 or 86.9%. Okay, so the final answer, the probability that a randomly selected model victim in 2005 was male, given that the victim is 20 to 24 years old, is 0.869. All right. So now we touch upon general multiplication rule. Remember we did the multiplication rule before, but that has condition, that has requirement. Before, when we did multiplication rule, we say when E and F are independent, when E and F are independent, probability of E and F equal to what? Can you guess? Probability of E and F equal to probability of E multiply probability of F. That is, suppose event E and F are independent. When E and F are not independent, that is the general multiplication rule, use this formula here. Okay, so the probability of E and F equal to probability of E times probability of F under condition of E. That is the general rule. Now example. Again, this similar example context. In 2005, 19.1% of all murder victims were between ages of 20 to 24 years old. Also in 2005, 98.9% murder victims were male, given that the victim was 20 to 24 years old. What is the probability that a randomly selected murder victim was a 20 to 24-year-old male? You see the difference of this question between this question and this question here. This question is conditional probability given. Okay, this question asks you what is the probability? Okay, the person was male, given he is 20 to 24 years old. This is this question. And this question, what is the probability that a randomly selected victim was 20 to 24 years old and male? Okay, so what is the probability? It is male and 20 to 24 years old. It is and. So we use multiplication rule, probability of, use this rule here, okay. This probability is the same as probability of 20 to 24 years old and male. And male. And then you apply this formula, probability of E and F equal to probability of E times probability of F under condition of E. So once you are here, so this is E, this is F, probability E times probability of F under condition of E. Just try to make a notation. What is the probability of E and F equal to probability of E times probability of F under condition probability of E. Okay. So we know the probability of 20 to 24 years old is 0. This one here, I will try to use from The probability of 20 to 24 years old, 19.1%. 19.1%, okay. And the probability of male under condition 20 to 24 years old, this is the result we calculated in this example. See here, the probability of male under condition 20 to 24 years old, 0.869. So this number is this number. So multiply those two together, you get 16.6%. Okay. So this is a general multiplication rule. All right. So that's all for this video. We did two major topics in this video. The first one, multiplication rule. Multiplication rule have two cases. The first case is independent event. The second is the general rule. And the second topic, we did conditional probability. Okay. Thanks for watching. I look forward to see you next time. Bye.